Hi, 7th grade. Welcome to lesson 4-5, factor expressions. By the end of this lesson, I want you to be able to say, I can use common factors and the distributive property to factor expressions. Let's explain it. Tasha is packing gift bags that include the same items. She has 72 glow sticks, 36 markers, 24 bottles of bubbles. Tasha believes that she can pack no more than 6 bags using all of her supplies. Do you agree with Tasha? Explain. So let's see, if we have 72 glow sticks, 36 markers, and 24 bottles of bubbles. And she wants to pack 6 bags. So we got to figure out how much is going to be in each bag. So what are we going to do to each number? Divide. So if I divide 72 by 6, let's see, that's 10, 11, 12. Right, let's double check. Yep, 36 divided by 6 is 6, and 24 divided by 6 is 6. No, 24 divided by 6 is 4. So if she makes 6 bags, she can put in 12 glow sticks, 6 markers, and 4 bottles of bubbles in each. So yeah, she can do that, but is that the most number of bags she can pack? Because I see the numbers 12, 4, and 6 are all divisible by 2 as well, which means that I think we could pack 12 bags. Let's see. We could do 72 divided by 12, which gives us 6. 36 divided by 12, which gives us 3. And 24 divided by 12, which gives us 2. So if she wanted to pack 12 bags, it would have 6 glow sticks, 3 markers, and 2 packs of bubbles each. Oh, and that answers B, because B says if Tasha creates the greatest number of gift bags, how many of each item is in each bag? Explain how you know. Tasha added more markers and now has a total of 48 markers. Does this change the possible number of gift bags? Explain. So instead we have 72 glow sticks, 48 markers, and 24 bubbles. So if we stick to our original of 12 bags, we could divide all these by 12. That's called the greatest common factor. That's what we're doing today. 72 by 12 is 6 glow sticks. 48 by 12 is 4, so that's 4 markers. And 24 by 12 is 2 bubbles. Well, I see 6, 4, and 2 are all divisible by 2, which means we could make 2 times as many bags. So instead, we are going to take 72 and divide it by 24, 48 and divide it by 24, and 24 divided by 24. So 72 divided by 24 equals 3, so that would be 3 glow sticks. 48 divided by 24 is 2, so that's 2 markers. 24 divided by 24 is 1. So we can make 24 total bags. They just have less materials in it. All right, example number 1. Factor expressions. Kiana painted a rectangular wall blue to start an ocean mural. She used 3 cans of paint, each which covered X square meters, and a different sized can that covered 12 square meters. What are the possible length and height dimensions of Kiana's mural? So the expression 3x plus 12 represents the area of the mural, because each can covers X square meters, and we used 3 of those. And then she used a different can that covered 12 square meters. So adding those together gives us our total area, 3x plus 12. But you can see that 3 and 12 is the GCF. 3 is the GCF of 3 and 12. Because 3 can multiply into 3 and 3 can multiply into 12. So what we do is we divide that 3 out and we say, okay, 3 times x equals 3x and 3 times 4 equals 12. So 3 outside of the parentheses equals x plus 4. So kind of how I always solve these, we start with our expression, 3x plus 12. I think of my GCF of 3 and 12 and I divide it out. When you divide it out, it does not disappear. It goes on the outside of the parentheses. Then when we divide, we write on the inside of the parentheses what's left over. 3x divided by 3 gives you x. 12 divided by 3 gives you 4. If we wanted to check our work, all we would have to do is distribute. Remember that from last lesson. Distribute means to multiply. 3 times x equals 3x. 3 times 4 equals 12, and we're back to our original expression. Use factoring to write an expression for length of the pool with a given width. So we have 4x plus 20. I'm looking at these two numbers, 4 and 20. Well, they're both divisible by 2, but they're also both divisible by 4. So you always want to take the greatest common factor. If you're not sure, you can write what's called a factor rainbow. So I know 4 is 1 times 4 and 2 times 2. So 1, 2, and 4 are my factors of 4. 20 is 1 and 20, 2 and 10, and 4 and 5. So those are all my factors of 20. So then you look for the biggest one that they both have, and I see 4 and 4. So that's what I'm going to divide by. I divide by 4 on both sides, but the 4 does not disappear. It goes on the outside of the parentheses. Then what goes on the inside of the parentheses is what's left over when you divide. So we divide 4x by 4, and we're left with x. And we divide 20 by 4, and that gives us 5. So if we know that the width is 4 meters, length times width, the length of the pool has to be x plus 5. And again, how do we check our work? Oh, that's the convince me. How can you use the distributive property to check your factored expression? Use the factored expression in example 1 for your explanation. Well, we already explained that, so let's use our factored expression in the try it. 4 times x plus 5. You distribute, you multiply. So I multiply in 4 times x is 4x. 4 times 5 is 20, and that's our original expression, so we are good to go. Example number 2, factor expressions with negative coefficients. So what I always want you to do, don't pay attention to this first box, if ever the first number is negative, I want you to pull out the negative factor. So you can look between 2 and 6, what's the greatest common factor? So I've got 2, I know the only numbers that multiply to 2 are 1 and 2. I've got 6, so that's 1 and 6, and 2 and 3. My greatest common factor on both of them is 2. So I'm going to pull out a 2, but the beginning number is negative. So I'm going to pull out a negative 2. What I mean when I say pull out, I mean I divide by negative 2. So I've got negative 2x minus 6. I'm going to divide by negative 2. But please remember, when you divide, it does not disappear. It goes on the outside of the parentheses. Then when we divide, what goes on the inside is our quotient. Now, negative 6 divided by negative 2 is positive 3. So our answer is negative 2x plus 3. Remember, we can check by distributing. Always check. Negative 2 times x is negative 2x. Negative 2 times positive 3 equals negative 6. That's our original expression. Now, if you weren't to divide out the negative 2, you might mix up something with the signs. So that's why checking is important. So instead of showing two different ways, we're just going to factor negative 4x minus 28. So I'm trying to find the factors of 4 and 28. So I know 4 is 1 and 4 and 2 times 2. 28 is 1 and 28. 2 and 14. Does 3 go into 28? 4 goes into 28. 4 and 7. Does 5 go into 28? Nope. Does 6 go into 28? Nope. So then I'm looking for my biggest number that they both have in common. That's 4. But remember, the first number, our first term is negative. So I'm going to divide out -4. Divide out the GCF as negative. So remember, when you divide it out, it does not disappear. -4 divides out with -4. I'm left with x. -28 divided by -4 is a +7. And that's our answer, but we can always check. I distribute, which means to multiply. -4 times x is -4x. -4 times +7 is -28. And boom, that works. Example 3, factor 3 term expressions. So that's when we have 3 terms. So we've got 6x, -18, and -12y. First, I check to see if I can combine them. They are not like terms. One is an x, one is a constant, and one is a y, so I can't combine them. So I find the GCF of 6, 18, and 12. So the factors of 6 are 1 and 6 and 2 and 3. 1 times 6, 2 times 3. Factors of 18 are 1 and 18, 2 and 9, and 3 and 6. And the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So we can see 6 is our GCF, our greatest common factor. So that means we're going to divide 6 out from everything. Now 6, the leading term, is positive. So you can divide by a positive GCF. You don't have to divide by -6. You're going to divide by +6. So when we divide, remember, it does not disappear. 6 divided by 6 is x. -18 divided by 6 is -3. -12y divided by +6 is -2y. And that's the same answer they have here. How can we check? Distribute. 6 times x is 6x. 6 times -3 is -18. 6 times -2y is -12y. And boom, that was our original expression. Okay, so this says write an equivalent expression for the expression above using a negative factor. So 6x minus 18 minus 12y. Now they want us to do the negative factor, so we're going to divide by -6. You won't have to do this unless they ask you to. So I put a -6 out front. +6 divided by -6 gives me -1x. -18 divided by -6 gives me +3. -12y divided by -6 gives me +2y. These are still the same expressions. One just has a negative GCF. Again, we can check by distributing. Does not hurt to practice this and to check our work. -6 times -1x is going to be +6x. -6 times +3 is -18. -6 times +2y is -12y. And that was our original expression. All right, 7th grade. Let's go back and say it. I can use common factors in the distributive property to factor expressions. Have a great day.